Okay, so this video covers question 8 of the OCRA 2019 Further Stats paper. The test required is a non-parametric test called the Wilcoxon Rank Sum Test. There's a number of things that point in that direction. I suppose the most basic of these is non-mathematical at all. There is no other non-parametric question on the test paper, which would seem unlikely, I suppose. It's not really a good way of looking at it, but it's a kind of it's reassuring to know that there isn't one else other. We've got different sample size, 30 and 24. It's not paired because of that, because we're talking about different students anyway, and in any case it's impossible to be paired if you have different numbers in each group. And we're not told anything about the parent distribution, which indicates a non-parametric test. Okay, so we got to set up the hypothesis, just to do a hypothesis test. We've got two different professors and again different rankings from each of the students. So they're getting slightly different scores or ranked, and the idea is they're being ranked as 31 group and 24 in the other. So they've got a ranking from 1 to 54, and what some of those will be Professor P's Q students, and some will be Professor R students, and we want to know if there's a difference in the median rankings of them. So to set up the null hypothesis, we say the medians of the rankings because we don't have the actual scores themselves of Professor Q students is equal to Professor R's. Then the alternative hypothesis, the medians of these rankings are not equal. So it's a two-tailed test because we're not talking about a more or less. Are not equal. Okay. You are given some help in the formula book. You're given critical values, but they don't go as high as 24 and 30. So this is going to end up using the normal approximation for that, which we'll talk about, because of course that's a continuous distribution, whereas the sums of rankings is a discrete distribution. Right, so the first thing to note is that we are given the sum of the rankings of those taught by Professor Q. That's the larger of the two, because M is 24 and N is 30. So M is associated with Professor R students and N is associated with Professor Q students. We need the ranking for the smallest one in order to follow the procedure. So we have RM is equal to, right now, we're given the ranking of the 30 students of Professor Q. Well, the numbers 1 to 54 all added together using like the counter numbers, triangle formula for sum of triangle numbers or whatever, is equal to 54 times 55 divided by 2. That formula we're using is n plus 1 divided by 2. Take away the 726, comes to 759. Okay, so 759 is the ranking for Q, which is what we need. No, for R, which is the smaller one. RM is 759. Now, if we were dealing with the critical values, we would need to check which side of the tail we're on by actually working out this kind of quantity here. if we were having to work with the critical values, because the critical values only work if we're working on the left hand side of the tail. But we'll be able to see when we work out these approximations which side of the tail we're on anyway, so it's unnecessary to do this part if you're using the normal approximation. You can do, but it's just wasting your time. So let's work out these quantities for the mean and the variance. So the normal approximation would give us the mean is equal to half m plus n plus 1. That's equal to half times 24 times 54 plus 1, that's 55, and that comes to 660. And then the variance again, this is given to us, half m plus n plus 1. You could just times this one by n, I suppose, or you could just work it out again. Either way, you'll get, let's just work it out again, half times m, which is 24 times 30, so useful check, and then check using the other one. So that times by 55, and that comes to 3,300. Okay, so it's approximately, this RM distribution is approximately normally distributed with mean 660 and standard deviation square root of 3,300 or variance 3,300. Okay, so that's the approximation we're using. Now, this going back to the normal distribution and to the reason why we don't need to work this number out, we can see from our normal approximation now, we've got a value 660 for the mean, but our actual value for RM is equal to 759. So we know we're on this side of the tail, and we want to find out an approximation for this. Actually, I probably shouldn't have put 759 there, because I need to talk about a continuity correction, and that's important in a moment. So I'll put that up in a moment when we dealt with the continuity correction. So we want to find out an approximation, so we want the probability that RM is greater than or equal to 759. And in this case, the type of inequality is important because it needs to be an inclusive inequality. Right, now look, we're going to approximate that. Let's put the approximate sign in just to emphasize that. We're going to approximate that to the normal distribution with this continuity correction. Now, the way I think of the continuity correction is we need the number here. Imagine we're dealing with the number 759. We're going in this direction. Right, now when you're doing the continuity correction, you need to extend backwards by a half from whichever direction the arrow's going. So you're always extending the line. If it were going that way, the extension would be that far if the arrow were that way. So we're always extending kind of further backwards. So that means it's this number I can put in now, 758.5. We're going back. So that means probability that this distribution, let's let that x is greater than or equal to, it's arbitrary now whether I have a inclusive inequality or not, because it's a continuous distribution. Right, now we're going to use OCR expect us to use calculators for this. They don't give us tables anymore, which is good. It's quicker to use a calculator anyway. But the one thing, depending on the calculator you're using, we tend to use the FX991, the Casio, EX, the ClassWiz. That's the number that we're working. The calculator gives us a cumulative with the inequality going in that direction. So we really need, before we use the calculator, to change the direction of the inequality. So that's x less than 758.5. I've changed the type of inequality here, but I didn't really need to. It's arbitrary because it's continuous. But students tend to like me to be consistent, so there we go, so that we don't make the, I suppose, so that we wouldn't make that mistake if it were discrete, because obviously then it would be important. Okay, so now we're going to go to the calculator, bring up the class whiz. Okay, so we go to 7, and we want the normal cumulative, so that's 2. The lower end, right, now the lower end, obviously when we're going to this side, we need to pick a number that's sufficiently small. You don't need to go over the top, don't need to put 9 times 10 to the 90, or minus 9 times 10 to the 99 in. 0 would be pretty small here because we've got a mean of 660 and a standard deviation of, well, yeah, 60 odd, or so 50, 60 odd, but so 0 would definitely be small enough to get a very accurate answer. The upper tail is 758.5. The standard deviation that we're dealing with, you can put the square root figure in your calculator. It will deal with it whilst you're working with this function, so that's 3,300, the square root of that. And the mean is equal to 660. And so we have the number 0.568. So 1 minus 0.9568, which is equal to 0.032. Now, this would, if it were a one-tailed test, that would go below the threshold, but that is greater than 2.5%, which is, because it's two-tailed, 5% threshold for, or critical value for two-tailed. So that means it's not, it's not extreme enough, it's not significant enough. So therefore our conclusion is we do not reject H0. There is insufficient evidence to suggest the median ranking rankings of students taught by Professor R is different to that of Professor Q. Okay, so that's it. Do the test right, get the wording right, and I think it's a nice easy way to pick up 10 marks on this. So hopefully you found this video useful. It basically covered an important aspect of the course. Wilcoxon ranked sum test, a non-parametric test using the normal approximation, and not forgetting the continuity correction. Okay, that's it, and I will do the final question in due course. Bye.